The kinetic energies of the planet in the elliptical orbit about the sun the kinetic energies of the planet in the elliptical orbit about the sun at position A, B, and C are. That is given. So we have to take a elliptical path. In that, this is major axis and minor axis. This is point A, this is point B, this is point C. The kinetic energies of the planet in the elliptical orbit about the sun is here. At that is at focus. And the question A, B, C are Ka. Here the kinetic energy is Ka. Here kinetic energy is Kb. Here kinetic energy is Kc. What is kinetic energy? Ka equal to half m Va square. The same way we can write for Kb and Kc. So half m is constant. That's why Ka is proportional to Va square, velocity at that point. Kb equal to proportional to Vb square. And Kc is proportional to Vc square. Velocity at that point, kinetic energy. But velocity for that point at A will be Va is greater than Vc. Suppose the planet is rotating this way, in the anti-clockwise direction, then Va is greater than Vc. This is because suppose in dt seconds, this A to A dash is dt seconds. The time area covered by this displacement of this planet is A dash S. A dash S. The same width if we take C dash, same distance we take and if we join, you will get this much area. But the planetary motion is having the property of aerial velocity. Time taken for aerial velocity are equal. Suppose the CC dash, same distance, but it has twice the area of this. Means, suppose for this A to A dash time taken, A dash to A time taken is T1 means it will take 2 times T1. T2 equal to Tc equal to 2 times Ta. Here Ta let us assume. Because the area is double, same distance. CC dash is same distance, but area is double. It covers the area of double from the sun. That's why it takes 2 times. So here at T1 same distance, at Tc same distance, but area is large. That's why it has to spend more time, twice the time of this it has to spend, because time taken for area covering must be equal. That is called aerial velocity must be equal. That's why S, time taken to cover A dash S is equal to Ta, means time taken to cover C dash S equal to 2 times Ta, because area of C dash S is 2 times A dash S. That's why this Va will be higher than, always Va is higher than Vc. Here Vb is approaching A but leaving C. Therefore, Va is higher, VB is in between and VC is less value. Therefore, kinetic energy A is proportional to VA. Kinetic energy at B is proportional to KB. Therefore, kinetic energy at C is Kc is proportional to VC square. Therefore, this is the correct relation between kinetic energies. Therefore, D is the answer. D, B, sorry, not B, D, B is the answer. D is the answer. Are you able to understand? Aerial velocities are equal. Suppose it covers, let us assume this way. Here the area covered is A dash. Yes. Here also it covers the same area. Thin, then only area will be equal. Time taken for this is C dash. Yes. Area is equal. A dash S is equal to C dash S. Area equal to area covered. Therefore, time taken to travel A dash equal to time taken to travel C dash. The same time it traveled a small distance only. That's why here slow, here fast. That's why VA is higher. That's why kinetic energy at this point is higher. That's all. Shall I move to next sum? Giri? A planet moving along an elliptical orbit is closest to the sun at a distance r1. It's not ellipse. It's not ellipse. Here is the sun. A planet moving along the elliptical orbit is closest to the sun at a distance r1 and farthest away at a distance of r2. If v1 and v2 are the linear velocities at these points, here v1, here v2, then the ratio is, what is the ratio? We have to find. We know that momentum is equal. Kepler's law, as per Kepler's law, momentum at A and momentum at B are equal. That is m v1 r1 equal to m v2 r2. M getting cancelled. That is L1 equal to L2 or V1 by V2 equal to R2 divided by R1. What is the question? The linear velocities at this point respectively, then the ratio is V1 by V2 is R2 by R1. R2 by R1. Therefore, B is the answer. So we are here, what is the point? Logic is momentum, angular momentums are equal. Angular momentum are equal. Angular momentums are equal. M V1 R1 equal to M V2 R2. Where M is the mass of the planet. Where M is the mass of the planet. Shall I move to next sum? The figure shows elliptical orbit of a planet. M, about the sun. S, the shaded area SCD. S, C, D. SCD SCD, the shaded area SCD is twice area SCD equal to twice the shaded area of, as per diagram, SAB, area SAB. This is doubled 2 times. T1 is the time for the planet to move from C to D. Here time taken is T1. T2 is the time taken to move from A to B. This is T2. A motion from B to A, it covers an area of SAB as it moves from B to A. As it moves from B to A in T2, it covers the area SAB. Here, as it moves from D to C, in time T1, it covers an area. It covers an area SDC. SDC. The area is twice. Area is twice. Therefore, T2 must be, or T1 must be 2 times T2. Here T2. This area, if you compare, this is 2 times higher. Therefore, T1 equal to 2 times T2. T1 equal to 2 times T2. B is the answer. Shall I move to next sum? The period of revolution of a planet around the sun is 8 times that of B. This is sun. 2 planets, A, another planet is B, are not in the same path, a different path. The period of revolution of planet A around the sun is TA. Around the sun is 8 times that of TB. The distance of A from the sun is how many times greater than that of B? The distance of A Nitra, Asini, 2 logins are there. The period of revolution of planet A around the sun is 8 times that of B. The distance of A from the sun is how many times greater than that of B? Kepler's third law says that we are not going to see any theory. When then and there, whatever the theory required, that we will see. The period square, time taken to complete one revolution is T. T is proportional to the radius. Radius means we know this is R1, this is R2. R equal to R1 plus R2 divided by 2. That is the radius. R cube. So the distance from S. So the distance of the planet from sun is depends upon R. We know that T square equal to R proportional to R cube. Therefore, TA square divided by TB square is proportional to a ratio. That's why we can put equal. RA cube divided by RB cube. By knowing this relation, we can write. But TA equal to 8 times that of B. TA equal to 8 times TB. So we can substitute 8 TB divided by TB square equal to RA cube divided by RB cube. Shall we write like that? TB square getting cancelled. Therefore, RA cube divided by RB cube equal to 64. Or we can say that RA by RB equal to 64 can be written as 4 by 4 by 4. So the cube root of 4 by 4 by 4 equal to 4. Therefore, RA equal to 4 times RB. RA equal to 4 times RB. A is the answer. Shall I move to next sum? The distance of two planets from the sun are RA. Distance RA from the planet A is 10 power 13 meter. Of this, another planet is 10 power 12 meter respectively. Ratio of the time periods of the planets. We know that TA is proportional to RA cube. TA square. TB square is proportional to RB cube. So we can write TA divided by TB whole square equal to RA 10 power 13 divided by 10 power 12 whole cube. That is equal to 10 cube. 10 cube. 10 power 13 divided by 10 power 12 equal to 10 cube. Or you can say that is equal to 10 multiplied by 10 multiplied by 10. Therefore, TA divided by TB whole square or TA divided by TB equal to square root of 10 multiplied by 10 multiplied by 10. These two are 100. That's why that is equal to 10. This you have to keep as such root 10. 10 root 10. Therefore, TA by TB equal to the ratio of the time periods equal to 10 root 10. B is the answer. Shall I move to next sum? A planet is moving in an elliptical orbit around the sun. T, V, E, and L are kinetic energy, gravitational potential energy, total energy, and angular momentum. About the center of force, which of the following is correct? T is conserved. Angular momentum is conserved. Then potential energy and total energies are negative. potential energy are negative. Always for this gravitational potential energy is negative. Always. Total energy also negative. Then kinetic energy increases with increases velocity. It increases because here when it is very close to sun, its velocity is higher. Increases with linear velocity. Then what we know, direction of L does not change. Direction of L does not change. Does not change. These are the properties we know. Based on that, if you see T is considered wrong. V is always positive, wrong. V is what? Gravitational potential energy. That is negative, you know. E is always negative. Yes, this is correct. L is conserved, but direction of vector L changes continuously. L does not change its direction. Therefore, D also wrong. Therefore, E is correct. E is always negative. That is, total energy is negative. Shall we move to next sum? The largest and the shortest distance of Earth from the Sun are R1 and R2. Sun is here. This is R1. This is R2. Shortest and longest distances are R1 and R2. Its distances from the Sun when it is at a perpendicular to the major axis of the orbit drawn from the Sun is. This is the perpendicular distance. The distance from the Sun when it is at perpendicular to the major axis. This is the major axis. This is the major axis. Sorry. Major axis of the orbit drawn from the Sun is. This is the perpendicular drawn from the Sun. The distance from the Sun. Let us assume that let it be R. It is. Mathematical expression for R is 2 by R equal to 1 by R1 plus 1 by R2. You have to remember this expression, no other go. 2 by R equal to 1 by R1 plus 1 by R2. Therefore, 2 by R equal to R1 R2, R2 plus R1. Therefore, R divided by 2 equal to R1 R2 divided by R1 plus R2. Therefore, R equal to 2R1 R2 divided by R1 plus R2. 2R1, yes, C is the answer. So we have to remember this relation for planet motion. Sorry, property of ellipse. Property of ellipse. Shall I move to next sum? Okay. A body of mass 60 gram. 60 gram equal to 60 into 10 power minus 3 kg. Experiences gravitational force. Gravitational force equal to 3 Newton. When placed at a particular point, the magnitude of gravitational field intensity at that point is, we know that E equal to gravitational field intensity E equal to F divided by M. We know F by M. The magnitude of gravitational field intensity at that point equal to F by M, field divided by mass. This is how we got is, we know that F equal to G M small m divided by, this is planet mass, this is earth mass, uh, divided by r square. R is the distance from center of the earth to that point. E equal to F by M. That's why this is also can be written as F by M equal to Gm divided by R square. This is also we can write Gm divided by R square. What is asked? The magnitude of gravitational field intensity. Field intensity E equal to F by M. That is equal to what? Therefore, the magnitude of gravitational field intensity at that point is F equal to what? 3 divided by 60 into 10 power minus 3. That is equal to 3 divided by 6 into 10 power minus 2. That is equal to 1 by 2 into 10 power 2. That is equal to 0.5 into 10 power 2. That is 50 Newton per kg. Newton per kg. This is Newton. This is kg. Therefore, Newton per kg. The field intensity at that point is 50 Newton per kg. Therefore, B is the answer. Shall I move to next sum? This may be useful in some other sum. Here F by M. E equal to F by M. That's all. Field divided by mass. Sorry. Field equal to force divided by mass. Intensity. Field intensity equal to force divided by mass. Gravitation force divided by mass. Next sum. Two astronauts are floating in gravitational free space. Two astronauts are floating in gravitational free space after having lost contact with their spaceship. They are floating in the space. What will happen in the charges? While we study about force between electric charges, we have seen that if the two charges are positive, they will repel each other. When the two charges are opposite, then they attract each other, like that we studied. But here, gravitational force means they will always attract each other. That's why the two will move towards each other. That is correct. Move away from each other is wrong. Will become stationary is wrong. Keep floating at the same distance is wrong. Therefore, move towards each other is the correct answer. Therefore, A is the correct answer. So, always they will attract each other. Because two masses, they have their own gravitational force. That's why they will attract each other. Shall I move to next sum? Okay. Kepler's third law states that square of the period T square of a planet around the sun is proportional to third power of average distance radius square between the sun and the planet. T square is proportional to R square, or T square equal to KR cube, where K is a constant. K is a constant. If the masses of the sun and the planet are M and M, M, capital M and small m, respectively, then as per Newton's law of gravitational force of attraction between them is F equal to, this also we have seen, F equal to G, G is gravitational constant, GMM. I didn't tell, but now we'll see. G means gravitational constant, M, small m, divided by R square. This is the force of attraction between them is the G is the gravitational constant. G is the gravitational constant. Okay. The relation between G and K is, what is the relation between G and K? We know that F equal to GMM divided by R square. That is equal to, that is also equal to, this force is nothing but a centripetal force. So we know that centripetal force is mv square divided by r. So we are taking this relation. So g m small m divided by r square equal to mv square divided by r. R square r getting cancelled, small m getting cancelled. Therefore, v square equal to v. This implies v square equal to g m divided by r. Gm divided by r. Let it be 1. Let it be 1. We know that time period equal to, we know that time period, because relation is for time period is given. K r cube. This K, want a relation between this K and G, we want a relation. We want a relation between K and G. That's why take time period. Time period equal to what? Let us assume that it is circular. 2 pi r perimeter divided by velocity. That is time period. Therefore, we can write this implies t square equal to 4 pi square r square divided by v square. Substitute that v square here. Therefore, t square equal to 4 pi square r square divided by gm divided by r. Or t square equal to 4 pi square r cube divided by gm. This r goes to numerator. That's why 4 pi square r cube divided by gm. Or you bring the gm to the left hand side. You can write here. One more step we will write. I am writing. Here I am writing. T square equal to 4 pi square r cube divided by gm. T square equal to what? K r cube. Therefore, K r cube equal to 4 pi square r cube divided by gm. R cube also getting cancelled. Therefore, K equal to 4 pi square gm, or gm K equal to 4 pi square. Gm K equal to 4 pi square. Therefore, D is the answer. Therefore, D is the answer. So, any doubt in today's class? Understood? We have seen 10 sums. That's okay. No. Giri, got? After a long time, you are attending. Giri. Giri, got? Okay. No doubt. Okay. Shall we meet tomorrow? Tomorrow shall we meet? Okay. I